For each of the following relations, determine the domain and range and state whether or not the relation is a function. A relation is simply a rule that produces one or more output values, typically the y values, for every valid input value, typically the x value. The domain of a relation is the set of possible input values. The range is the set of possible output values. For many relations, the domain and range consist of all real numbers. For the domain, this can be denoted as XER, and for the range, as YER. Note that the XER is actually read, X is an element of the set of real numbers. For some relations, the domain and range consist of all real numbers only within a specified interval. On a graph, a closed or filled-in circle means that the interval includes the endpoint. The domain and range will use a greater than or equal to symbol or a less than or equal to symbol. A hollow or open circle on a graph means that the interval does not include the endpoint. The domain and range here will use a greater than symbol or a less than symbol. For some relations, the domain and range consist only of a selection of real numbers. Here, to list the domain, we would write X is an element of, and then a list of values inside a set of curly brackets, also called set braces. A relation is a function if and only if only one output value exists for each input value. We can use something called a vertical line test to check if a relation is a function. To do this, a vertical line can only intersect the graph once, everywhere on the graph, for the relation to be a function. Let's consider the first graph. For the domain, we must consider the possible x values. Note the arrows on both sides of the graph mean that the graph continues infinitely in both the positive and negative x directions. This means that the domain consists of all real numbers, XER. For the range, we must consider possible y values. Note that we have a maximum y value of 8. The arrows also show that it continues infinitely in the negative y direction, so y less than or equal to 8, and we also must include that y is an element of the set of real numbers. Is this relation a function? Taking a look at a vertical line, this vertical line could only pass the graph once, everywhere. Therefore, this is a function. Note that for each input value, there can only be one output value. On to the second graph. For the domain, note that there is an open circle at x equals -8. This is the left point of the interval. This means that x must be greater than -8, which is the same thing as -8 less than x. There is a filled-in circle at x equals 10. This means that x must be less than or equal to 10. We also must include that x is an element of the set of real numbers. For the range, we have a minimum y value at -5. This means that y is greater than or equal to -5, or -5 is less than or equal to y. A maximum y value of 8. This means that y is less than or equal to 8. We then have the range -5, less than or equal to y, less than or equal to 8, and YER. Is this relation a function? Taking a look at vertical lines, Note that vertical lines anywhere between about x equals 0 and x equals 4 will cross the graph more than once. This means that for a single input value, there is more than one possible output values. This means that this is not a function. Now on to the third graph. For the domain, note that there is a closed circle at the point -6, -7. This means that -6 is included in the domain. We have an open circle at -1, -7, but then we also have a closed circle at -1, 1. This means that we must still include x equals -1 within the domain. Similarly, at the points 4, 1, we have an open circle, but then at 4, 6, we have a filled-in circle. We must also then include x equals 4 within the domain. We have an open circle at the point 9, 6. This means we cannot include 9 within the domain. We therefore have a domain -6 less than or equal to x less than 9. We must include all real numbers within that interval. For the range, note here that the y value can only be certain discrete quantities. We have to say y is an element of, and then inside some set braces, y can be -7. For the second portion, y can be 1. And for the third portion, y can be 6. Is this relation a function? Again, we can look at vertical lines. Note that vertical lines placed anywhere on this graph will only intersect the graph once. Therefore, this relation is a function.